Measure of spread. Variation range. Range. One of the measurements of variation in the data is range. It is the simplest measure of variation and is the difference between the highest and the lowest values. It represents the end-to-end spread of the data. How many data points are we replacing when we move from the highest value to the lowest value or from the lowest to the highest value? Range equals maximum minus minimum. Here, maximum is 21 and minimum is 2. Hence, the value of range would be 21 minus 2, which is 19. That means when we are moving from the highest to the lowest value, or from the lowest to the highest value, we are moving by 19. Range should be targeted to be kept to the lowest possible. Variation quartiles. Quartiles. Quartiles, as the name says, divide the data in 4 parts, each covering 25% data. To divide the data in 4 parts, there are 3 quartiles, Q1, Q2, and Q3 respectively. To calculate quartiles, we need to arrange, sort the data in ascending or descending order. After the data is ranked, the first quartile from the lowest value side is Q1, below which is 25% of data, 75% of data is above it. Q2 is the midpoint of the ranked data, which is also the median. 50% of the data is above and below the Q2. Q3 is the last quartile from the lowest value side, or the first quartile from the highest value side. Below Q3 is 75% data, and above it is 25%. This image represents a box plot structure, breaking down a data set into 4 equal parts using quartiles. Let's walk through it from left to right. On the far left, we have the minimum value, which is the smallest data point in the data set. Q1, first quartile, marks the 25th percentile. 25% of the data lies below this point. Q2, median, is the 50th percentile. It divides the data set in half, with 50% of values below and 50% above. Q3, third quartile, is the 75th percentile. 75% of the data falls below this point. On the far right is the maximum, the largest data point in the data set. Each of the 4 segments between these markers represents 25% of the data, highlighting the distribution and spread. This visualization helps us quickly assess the skewness, spread, and central tendency of a data set. Note, the above formulae give the position of the quartiles, and we will need to calculate the values from the data. First quartile, Q1. First quartile, designated Q1, equals lower quartile equals splits, lowest 25% of data equals 25th percentile. Second quartile, Q2. Second quartile, designated Q2, equals median equals cuts data. Set in half equals 50th percentile. Third quartile, Q3. Third quartile, designated Q3, equals upper quartile equals splits, highest 25% of data, or lowest 75% equals 75th percentile. Quartiles example. Let's consider a simple example. Let's say we have a data set having data points as 4, 2, 8, 6, 10, and we need to calculate the quartiles for this data set. First, we will need to arrange the data in ascending or descending order. After arranging the data in ascending order, using the formulae, we will calculate the position of the quartiles. Here in our example, there are 5 data points, so using the formulae for quartiles, we have Q1 equals the quantity, 5 plus 1, divided by 4, which equals 6 divided by 4, or the first 0.5 data point. Similarly, we can calculate the position of Q2 and Q3, which will come to third and fourth 0.5 data point respectively. Let's consider a simple example. Let's say we have a data set having data points as 4, 2, 8, 6, 10, and we need to calculate the quartiles for this data set. First, we will need to arrange the data in ascending or descending order. After arranging the data in ascending order, using the formulae, We will calculate the position of the quartiles. Here in our example, there are 5 data points, so using the formulae for quartiles we have. In this example, Q1, the first 0.5 data point would be 3, Q2, median, the third data point is 6, and Q3, the fourth 0.5 data point is 9. Variation IQR. Interquartile range, IQR. IQR is the spread of the middle 50% of the data when the data is ranked in ascending or descending order. It is the difference between the third and the first quartile. This diagram illustrates the interquartile range, IQR, within a box plot. The IQR represents the middle 50% of the dataset and is calculated as the difference between the third quartile, Q3, and the first quartile, Q1. IQR equals Q3 minus Q1 from left to right. MN is the smallest data point. Q1 marks the 25th percentile. Q2, the median, is the 50th percentile. Q3 marks the 75th percentile. Max is the largest data point. Each section between the vertical lines, Q1 to Q2 and Q2 to Q3, represents 25% of the data, making the interquartile range span the middle 50%. The arrows highlight that the IQR excludes the lowest and highest 25% of the data, focusing only on the central values. This range is particularly useful for identifying data spread and detecting outliers. IQR equals Q3 minus Q1. Interquartile range, IQR, example. Let's move ahead with the example of data set that we considered while calculating the quartiles. We calculated Q1 as 3 and Q3 as 9, hence the interquartile range, IQR. Here would be Q3, Q1, which would be IQR equals Q3 minus Q1. IQR equals 9 minus 3 equals 6, which implies that the difference between the third and the first quartile is 6, or the spread of the mid 50% data is 6. Variation stability factor. Stability factor. Stability factor, SRF, as the name suggests, reflects the stability of the process. Closer the value of the stability factor to 1, more stable the process is. Stability factor equals Q1 divided Q3. Stability factor closer to 1 means that Q1 and Q2 are closer to each other. Stability factor exactly 1 means that Q1 is equal to Q2 and Q3 equal. Stability factor closer to 0 means that Q1 and Q3 are away from each other. Note it is again a measure of mid 50% of the ranked data. Stability factors example. Let's consider the Q1 and Q3 calculated in the previous example. Q1 equals 3, Q3 equals 9. Stability factor equals 3 divided by 9 equals 0.333. Stability factor away from 1 means the chi and q's are away from each other, i.e., there is huge variation between the MID 50% data. Variation variance. Variance. Variance is the measure of dispersion, spread, of data points from mean. To calculate variance, we calculate the squared distance of all the data points from mean, or x, take their summation and divide the sum by n-1, which is the degree of freedom. Let's assume we have a data set wherein the data points are x1, x2, x3, x4. Xn mean is, and total number of data points is n. Variance is equal to the sum of mean minus x1 plus mean minus x2 plus mean minus x3, and so on up to mean minus xn, all divided by n minus 1. Variance is equal to the sum of mean minus x1 plus mean minus x2 plus mean minus x3, and so on up to mean minus xn, all divided by n and minus 1. Variance is the average of squared distance of all the data points from mean. Variation, standard deviation. Variance. Standard deviation is the most preferred measure of dispersion, as is enjoys contribution from all the data points. To calculate standard deviation, We take square root of variance to nullify the impact of squared amplified values. Standard deviation way is equal to the square root of mean minus x1 plus mean minus x2 plus mean minus x3, and so on up to mean minus xn, divided by n minus 1.
Standard deviation equals the square root of the sum of squares divided by n minus 1. The square root of the sum from I equals 1 to n of x sub I minus x bar squared divided by n minus 1.
Standard deviation is the root of average distance of all the data points from mean. Key takeaways. What you learned. Statistics helps in data-driven decisions and process improvement. Mean shows average. Median gives middle value. Mode shows most frequent. Use median when data has outliers or is skewed. Range shows spread. IQR focuses on the middle 50% of data. Stability factor indicates consistency. Closer to 1 is better. Variance and standard deviation measure how spread out data is. Choose the right measure based on data type and variation.